Hi everybody, Luke Galan here from the YT624EJ maintenance channel. It really hasn't been that long since I filmed episode 20 on the carburetor maintenance, which by the way forgot to include the petcock filter. Check that thing. And one of the viewers online actually got me motivated to get going on another video. And I think maybe this is just a form of advanced procrastination that I've found here with these snowblower videos. But anyway, the Chute control motor. So the motor that makes the chute go left and right, one of the viewers online, I think Shane McLeod 99, was having an issue where his wasn't working well. So he kind of said, well, do you have a video on disassembly, repairs, etc. So there's nothing wrong with mine right now. So I think it's a perfect time to get a baseline, electrical baseline, voltages, currents. Everybody needs those waveforms. We can't live without them. And then after that, maybe we get the motor out, try to take it apart if we can without breaking it, because Luke doesn't want to buy another one at $500 and some. And then maybe try taking it apart, doing any maintenance, checking it out, seeing what's maintainable, not maintainable, getting some baseline readings, and then putting it back in. So anyway, thanks for watching. It always amazes me how much content can be made on a small, simple snowblower. And yeah, let's get going. So have a look at the manual. Thanks for watching. So here we have section 711 on the chute. And we see here the chute direction control motor, item 3. So actually, not much needs to be taken out to get it out. And then that's the rest of the chute disassembly. So here's the electrical section on the chute control motor. It only asks to check continuity. And if there's continuity, you're good to go. We'll probably check for resistance reading. And also, there's a little bimetal circuit breaker inside here. So if you do overload the motor, if the motor's stuck or the chute's stuck and you keep pushing on it, there's a thermal reset that'll take 60 seconds to reset. So that's a good note on that. So we'll get our trusty GIS screwdriver and get going on this job. Let's get the Viking spear removed. So we'll have to get the 10mm bolts off for the center cover. Now it's too bad we just got this cover back on because we're going to get it off now. And then we've got two 10mm bolts on this side. All right, to get the cover out of place, put the chute front and a little bit left. And then the cover is going to come out. So what we're going to do now is get a baseline on the motor, voltages and currents. The motor is right here, and then there's a small gearbox that turns this gear here. And so instead of trying to get in on the wire for the actual motor, I'm going to clamp on a clamp meter to the battery, and then I'm going to connect voltage to the battery. So I'll check the battery voltage and the battery current. We'll see what the battery current is supplying just the light, and then we'll actuate the motor both directions and we'll see what's going on. So here we've got the current monitoring the main red lead off the battery. So the current is coming out of the battery on the positive. Then we've got voltage measurement across the battery from negative to positive. So we're going to have a look at the oscilloscope now with some actions, and we're going to see what we get. All right, so here we have our snowblower at rest. It shows we have 12.0 volts on the battery, and it shows we've got 81 milliamps, but disregard that. The value's pretty well zero. This is just noise. So what I'm going to do now is we're going to look at the voltage and we're going to look at the current, and then we're going to turn just the key on, and just the light is going to come on. There we go. We've got the light that came on, and we're at about, let's see here, 416 milliamps. So we got about half an amp to keep that light on. And then the voltage is 11.9. And notice here the voltage is going to keep declining as long as that light's on. So what we're going to do now is we're going to operate the chute in both directions. Let's operate the chute in both directions rapidly, and we'll see what the current does. So one direction, the other direction. So we're going to go again and show the current. So we've got there about 3 amps in both directions. Now let's set up a trigger out of curiosity, and we're going to have a look on what it looks like at the exact moment that it picks up. All right, so here we've got a single trigger set up for 6 amps. So we're going to give that a try, and we'll zoom in on exactly what's going on when we activate the chute. So there we can see that the current, when we activate the chute, kind of shoots up, and when the chute starts moving, the current comes back down. So we can actually zoom in on that. So we can see that if 0 amps is down here, we've got about a 10 to 11 amp peak. The peak, I'd say, is about a 25 millisecond peak. And after that 100 milliseconds, it's come down to its nominal value, and then it stays at that value. And then we see that the level of current, we've got about 3 amps continuous. And this is going to keep going for as long as we actuate the chute. So where are we now? We're still at 11.9 volts on the battery. Now, if we observe our battery voltage, we can bring a cursor down, and the battery voltage dropped down to 11.4. And we were previously at 11.9. So you can see there we've got about a 500 millivolt drop roughly. And we can zoom into that. So we can see that voltage drop as soon as the chute comes on. And then as the chute current kind of goes down, we have the voltage that comes back up as well. I think this is good. We have to keep in mind as well that the light is also on and adding on to that current. So the 3.3 amps will subtract half an amp, and we'll get to about the 2.8 amp mark just for the chute motor to operate. And the current's always going the same direction. That's because the switch that we maintained in one of the last episodes, it alternates the polarity through the motor, but it's always coming out from the battery, from the positive terminal. If we looked at the voltage on the motor, we could see that the voltage changes directions both ways. All right, now we're going to try to naively take the 3 bolts out to get the motor out while still attached, and we'll take the connector off after. Now you'll want the chute in this orientation so you have easier access to the bolts. All right, here we see the motor has come out, and now we can push on this tab here on this side of the connector to get that connector to pop off. Push on that. Okay, like most everything else that goes through the shop, we gotta clean it. Some beautiful salt and sand. All right, here we have the resistance of 0.9 ohms, 0.8, minus the lead resistance of 0.1. So we've got like a 0.7 ohm resistance. We can't really turn this shaft because there's the gear, the worm gear in there. We're gonna try dismantling this now. We see in here, so the connector goes in here and goes into the motor. And what we could probably do is measure the resistance while we turn it. And we're probably going to get every pole of the small DC motor. I suspect there's brushes in here, but I do not want to get it out. So, and then in here, we've got the gearbox. So the gearbox, we've got the input shaft there. And let me turn it a little bit here. So we've got the input shaft here, and we'll see the output shaft turn with it here. So we can actually figure out the reduction ratio. 80:1 is what it is. Now, can we see any indication of that on here? No, I don't see anything about 80:1. Now we see that in this area here, this small vent on the back side connects to in here. So if we unwind this to the left instead of to the right, we'll see how it pulls out here. Here's our little worm gear. This worm gear looked really well lubricated. There's 0 signs of contamination on this worm gear. So we can kind of put that to the side. Now we come to the part that I really wasn't wanting to do, but for viewership I will. We'll take my only snap-on screwdriver. And to get the back of this gearbox off, I see 2 small tabs. So I think what we need to do is pry these tabs just to say gently until they're just free. And then we'll hammer them back in afterwards. So now that those are off, we can kind of, just to say, have them. I think it might be time to end this unnecessary maintenance because somebody's starting to question if the snowblower is really broken or what's going on with it. Isn't this thing brand new? Isn't this thing worth lots of money? Isn't this the best one we were supposed to get? Weren't we gonna not have broken snowblowers because we spent triple? Lots of questions are coming now and it's hard to answer them all. It's not really meant to be taken apart, to be honest. But here at the Luke Gallant Maintenance Channel, we do what needs to be done. Oh, so there was some pretty awesome sealant there, which we just lost. This almost looks like acoustic sealant, to be honest. So I'm going to clean that off. All right, so we managed to decompose the gearbox. We've got the wheel, then we've got a rubber dampener, and then we've got the top part here. which is spline here with 4 splines going onto the shaft, and then this is what controls the chute. So for myself, for what, 7 years of operation, this is really good shape. I have 0 complaints on this. There's absolutely 0 infiltration to this of any kind. You can see the grease is getting a little bit dated, so what I'm going to do is wipe some of that off and I'll re-grease. I've got nothing to complain about. Here we got the kind of the yellowing of the grease. Now it was very messy sealant I need to redo, so I'm going to remove that. Kind of interesting where the grease is a little bit yellow and stringy. And then on this little guy here, we've got 0 issues. It looks like it's brand new. So I'm going to leave that like that. And then the wheel, we'll have a good look at it. One of the pieces we forgot is to actually get this little guy out and have a look at it. So now that we've got this shaft out, we're going to take this little seal out. There's actually a washer there, and we'll have a look. This would be a place where infiltration could actually occur. So I'm going to have a good look at this and see what's going on. Almost forgot. That would have been bad. That would have been really bad, actually. I would have been kind of embarrassed. So here we have the shaft that comes through, actually facing up this way. And we've got this O-ring. This O-ring is a 2mm diameter O-ring, 8mm ID, and a 12mm OD. So this particular O-ring, I cleaned it up, and it looks in really good shape. So we're going to put it to the side and put this to the side. That shaft is 8.22mm, so the O-ring's a slight bit compressed, and then the space for the O-ring is 11.3, so we got a bit of compression in there. Alright, so here we're going to take a bit of alcohol and just wipe out all the grease residue, and then I'm going to put this brush in alcohol and just kind of clean the teeth a little bit to get everything out of there. It was already pretty clean, to be honest, and then this one I already got quite clean. I can give it the alcohol treatment again just to make sure. Alright, so instead of the Yamalube grease on this one, I'm actually going to go with the Super Lube dielectric, silicone grease. And the main reason is because silicone greases are known to work very well with plastics. It's actually an online user that I noticed used that for their gearbox, and so I ended up looking this one up, and this grease actually will swell some plastics. Now I don't think it'll swell these plastics, but in any case I'll use a silicone one. So I've had this sitting outside about -15, and it's still very easy to work with and stuff, so it's not like hardening or anything, which is good. So what I'm going to do is put some grease in the teeth here and make sure that every tooth has some. Then we're going to get the back of the gear just to make sure, and then we are going to get the inside so that it's always lubricated. It's pretty well saturated. We'll drop that in there. Then we're going to put some grease on the worm gear. It's nice transparent grease to make sure that all the surfaces are always coated, because it's metal on plastic here. And then there's a spot at the end for the bushing, and there's another spot at this end for the bushing, so we'll make sure that it's grease coated. And then what we can do is put that back in there. I'm going to take a Q-tip. We're going to go in the clockwise manner to get that worm gear to drive in there. Oop, oh, never mind, we just kind of push it down. There we go. And now we've got that in there. So then what we can do is just kind of clean up the edge of it. So now we're going to put the rubber in there. Then we're going to put the top plate in there. We could put that same silicone grease on the inside of the shaft here. The silicone grease is quite good with rubber. What we're going to do is put the grease on. We're going to put the washer on the gear. We're going to put the O-ring on, and we're going to make sure that there's grease there. It's going to give a proper seal, so we can coat that in grease. And then from the other side, we're going to put that in. We're going to twist it, and then we're going to push it through and push it in nice and tight. So here we want to grab this special circlip. We want to get ready to open it. Then we're going to push down in order to make sure that we've got that. And we want to push it down. Make sure that it seats in there, because you don't want this coming off. A little bit too much grease on the surface here. We're going to clean that up and just try again. All right, friends, even after thinking the circlip was on, it wasn't on, and now I do have it on there. It's super subtle. You have to push on the back here to compress the O-ring that's inside, plus push down in the face to get that rubber compressed, and then the circlip will slide in. Anyway, so make sure it's on there. Flashlight, magnifying glass, Ask your kids if your eyesight's too bad, and then we're gonna proceed to installing the cover. All right, so we're gonna resume here. We wanna get this cover remounted. Now what I've done is the two side tabs, I've gone and bent the one tab almost square, and the other one I've left open a little bit. I don't have that neat acoustic sealant style stuff, so I'm gonna use good old Yamabond 4. This is gonna harden to a bit of a different rubber-like consistency. What we're gonna wanna do here is get this Yamabond on the center to outside perimeter, and we don't want to get it inside because it'll get caught in the gears, it'll make a mess. You definitely don't want to over apply this stuff. We'll check out the other side. It's kind of hard, so what I'm going to do there is take a screwdriver and just hammer in that tab. Not too hard. There. Now I'm sure that that's not coming apart. So what we're going to do now is spin that shaft in a clockwise manner and make sure that things still turn. Nothing's jammed up or bound. We can get rid of our Yamabond, excess Yamabond. Actually, we could put it in an area where we can see it as it dries to make sure it actually hardens. All right, so I got everything back together. And then when I tested it out, it wasn't working in one direction, which kind of happened on occasion last year, but I never thought too much of it. Actually, I thought it was in the switch. So what I've done now is I've removed the assembly and I've removed the gearbox from the motor. And when I try to move the chute to the right, nothing happens. I see a small increase in current, but nothing happens. And then left it goes. You see right there, it kind of wants to go, but it doesn't. So when I go to the left, we're getting full action. When I go to the right, we're getting a bit of motor movement. Something's stuck there. There we go. So that current there, we have about 130 millivolts. In the other sense, we have about 130 millivolts on my current clamp. 130 millivolts is about 1.3 amps. So I'm gonna try to take this motor apart to see what's up, because there's something up where see right now I'm moving the switch to the right and it's not going. So let's take this apart. All right, so here we have our motor, and to be honest, I'm not sure how it comes apart, if it even comes apart. I'm gonna try to push this. So there's nothing that can be disassembled from this end at all. All right, here we go. I don't know if this is good or bad. I hope it's not bad, to be honest. Okay, probably gotta, oh, we got the little shaft pop off of the tip, that's fine. I'm gonna pull that out. And it doesn't look too bad. So here we have the set of brushes. Here we have the little rotor. And try and get that pulled out of there. It's probably a magnet, right? So pulled out of there. And you gotta realize it's wanna get stuck in there, so you gotta pull it out. There we go. There we go, perfect. Very, very nice work, love it. So here we see that we have some commutator. So we're gonna polish that and get all that junk off there, all the brush wear. And we can actually check the resistance of each winding. And putting that to the side, we can look down inside and we can see there's a tiny bit of grease down there at the end. So we can check all that out. Then what we're gonna do is have an inspection of the brush area here. We might be able to actually clean and sand the brushes a bit. All right, we're gonna take some electrical contact cleaner and clean off the commutator ring here. Then we're gonna take a sharp knife and we're gonna make sure that that space exists. Then we're gonna use some 2000 grit sandpaper. Bit of compressed air. Now the brushes have a tiny edge at the back. It's quite hard to see. What I'm going to do is just take this knife and cut that small edge off the back of the brush, even though it's very, very small. So we're going to get assembling this. So first we're going to have to get the rotor into the brushes. So I'm going to try my best here to assemble this so you can see it. But we're going to put that in there. Then we're going to take a small pick and just move each brush individually, gently. All right, so now that the brushes are moved back, we can get that in there, and we see that it turns really nice there. It doesn't get caught or anything. You can feel a really smooth rotation. And now what we'll do is we're gonna hold the end here really tightly, and we're gonna slide that down very centered. We feel the magnet, and then we're gonna feel that kind of push down in there. Now we can turn that again, and we see that it turns fine. What I'm actually gonna do is see if I can clip on here for voltage sensing, so that when I hook it back up, I can see if it turns left or right, and I'll know if there's an issue, if I'm getting voltage here or not. So I've got the one lead of the motor hooked up. I'm gonna plug that connector back in. So I've got the connector plugged in. The other lead I'm gonna have to hold with the meter. So I got that now. I'm gonna turn the key on, and we're gonna measure for voltage. If the voltage that is showing up there would be low, say 4 volts, then we know that the problem's in the switch. You go to the right, go to the left. Okay, go to the right. Go to the left. Right. .17 volt. Let go of the switch. Go to the right again. All right, so what we're gonna do now is put the coupling on, the tiny little coupling. And then following this, we're gonna reattach the gearbox on. Now, if you notice, the gearbox has the air breather, and then after it's together, it's fully sealed. So I'm gonna set up to do an air test on this. So again, I'm gonna apply Loctite. So here we're gonna try prying this little vent off without breaking it. I think it's coming off. And now we can use one of these adapters. All right, it's been a few iterations. Let's go for the vacuum and the pressure test. We're gonna do the vacuum test here at 10 PSI. Here we have 10 PSI with no pressure increase of any kind, so we can release that pressure. And now we're going to do the pressure test at a 4 PSI. So here we put we put that in there. We go slowly up. We go to 4 PSI, and we can hold that there for a good, say 30 seconds. We want to make sure the needle doesn't move at all. And that makes sure that we're airtight. We're now ready to reinstall it. Here we are now going to install this small vent. So we push that in. There we are. All right, so here we go. We're gonna put this motor and gearbox back inside. 3 bolts that go here. We're gonna make sure we Loctite them. This connector is totally sealed, and there's 0 signs of contamination. So those connectors, I don't jam them full of dielectric grease. And I'm actually not gonna reconnect this till I get it reinstalled. So I'm gonna take this motor and gearbox, flip it upside down. So now that I've got that lined up, I can actually put the bolt and washer down in there and do the one up to at least hold the motor. So now we've got that motor held. We could take another bolt, Loctite. So you're gonna wanna manually adjust the chute to get the motor aligned. So just do that very carefully. All right, so the torque for these bolts is supposed to be 4 Newton meters, but this torque wrench only goes down to 5. And we're gonna do 5 in this case. So 5 Newton meters, which is 40 inch-pounds. Then we're gonna reconnect the connector. Then we're gonna turn the key on and test. We're gonna clean up a bit of the debris here and apply some grease. All right, here we go with final assembly, which you've seen about 20 times now. Here we go. All right, everybody, that's it for the Chute control motor video. I know it was a bit long, but I hope everybody can find some value in it. As a final resting point, this switch up here on my unit seems to be flaky, maybe 1 out of every 20 times going to the right. So I might have to take that apart and do something more in depth later. But for now, I'm assured that the Chute control motor is in really good working order. Thanks for watching. Please like and subscribe, and let me know if there's anything else you'd like to see, because I really like this suggestion and it gave me a lot to chew on, that's for sure. Thanks.